history of Schrödinger's wave equation and all the stuff related to it. Okay, so let's get started. So guys, as we know that while Einstein was explaining the photoelectric effect, he thought that if we think that light is both a wave and a particle, then it would satisfy all the conditions and all the effects that light would create in various experiments. So he imagined that if we take like a metal and start radiating light over that metal piece, so we'll observe that a lot of electrons are getting out of that metal sheet, are getting emitted, and due to this we got luster of the metals. So while he was thinking of explaining this effect, he thought that if these light particles are waves, if these light particles, which we call as photons, are waves, then they must have an energy level, a fixed energy level, or a quanta, because according to Planck, energy comes in quanta, which are also energy packets, small energy packets, and this energy is equal to hf, where h is Planck's constant and f is frequency. Okay, so he thought that energy then is directly proportional to the frequency of the light wave. So the light falling on this metal sheet must have a particular frequency in order to have an energy level. Okay, so while he was thoughting of this experiment, he also thought that if we change the frequency of the photon, then the electron will not be emitted. So then what was this thing? So if you consider that E for photon is equal to hf, h sub p, so if it is equal to h times frequency of photon particle, then there must be a frequency of this electron also, as announced by this scientist de Broglie. So if the energy of the electron is more than that of photon, let's say the energy of electron is E sub E, which is for electron, is greater than photon E sub p, then the electrons will not be emitted. Or in other words, we can say that if frequency of electron is higher than the frequency of photon, then the electrons will not be emitted. But if the frequency of photon particles is greater than the frequency of electrons, then the electrons will be emitted from this metal sheet. So for photoelectric effect, frequency of electron must be lower than the frequency of photon. And the another thing that we learn from this experiment is that E is equal to h times frequency, as per given by Planck. So when this debate stopped, that whether light particle is wave or particle, then another debate started, which was what would be the mathematical modeling of the waves which are in fact particles. So a scientist came, which was Schrödinger. He was usually called as Erwin Schrödinger. So he came and he put forward his efforts so that he could come up with the wave equation for these particles showing wave behaviors. So in this video we're gonna talk about the Schrödinger's wave equation and its derivation. So things you will need to concern before starting this is that you must know basic calculus, wave functions. Basic calculus like dx over dy or dy over dx, and like integral of integral of x squared dx, like these things. And wave function mainly like this thing, psi is equal to e to the power of I kx. And third thing you're gonna need is that E is equal to hf. And fourth thing is that E is equal to mc squared. And fifth thing is total energy. Energy is equal to E sub t is equal to, which is equal to kinetic energy plus potential energy. Okay, so let's get started. So as we know that total energy E sub t is equal to 1 by 2 mv squared plus potential energy. And 1 by 2 mv squared, we can write this 1 by 2 mv squared on multiplying this mv squared with not multiplying, but on further investigation we found that 1 by 2 mv squared can be written as 1 by 2 mv times v. And we know that mv is equal to p, and p v over 2 will be equal to kinetic energy. But if we write this p v over 2 as p squared over 2m, then it also will be correct. So Et is equal to p squared over 2m plus v. And if we take a wave function, say, let me change the color of this. If we take a wave function like psi, then psi will be equal to e pi e to the power of I times kx minus wt. This is just angular displacement, and this is the original wave function. So if we differentiate psi with respect to x, then it will be equal to d over dx for e to the power of I kx minus wt. Okay, so this will eventually be equal to, if you know that differentiation, then it will eventually be equal to ik times the original wave function, which is I to the power of I kx minus wt. So the first derivative of psi with respect to x will be equal to ik times original wave function, because this is, we are already proving this will be equal to this. So on further differentiation we'll get that the second derivative of psi with respect to x will be equal to d over dx for the original wave function, this derivative. So this will be equal to ik multiplied by ik psi, which is equal to ik squared psi. And we know that I squared is equal to -1. Therefore d squared psi over dx squared is equal to negative k squared psi. And for k we have defined k as, because k is equal to 2 pi over lambda, therefore lambda will be equal to 2 pi, 2 pi over lambda, 2 pi over k. So, and we also know that E is equal to mc squared. Therefore for particles which don't have any mass, we can write that m is equal to E over c squared. Okay, so then momentum of the light particle will be equal to P is equal to mc, which implies on putting this mass into this equation we get P is equal to E over c squared c times c. So this will cancel and it will turn out into P equals E over c. So now we also know that, as given by Planck, energy is equal to, energy comes in quanta, which are small packets, energy packets. So E is equal to h times f. And putting this E in this equation, we'll get P is equal to hf over c. And if you have learned any wave chapter in your physics notebook, then you will get this as f over c. You know that c is equal to frequency times wavelength. Wavelength is often denoted by lambda. So f over c will be equal to lambda. On simplifying this equation we'll get this. So this will be equal to lambda, which implies P is equal to h times 1 over lambda, or the inverse of lambda, which implies P is equal to h over lambda. As you know that lambda, as we previously defined lambda as 2 pi over k, then putting this lambda's value in this equation, will get P is equal to h over 2 pi, h over 2 pi divided by k, which implies P is equal to h over 2 pi times k. So we know that the Planck constant can be further equated as 2 pi over h over 2 pi will be equal to h bar. Okay, so on assuming this thing, we'll get h prime times h prime times, let me see, h prime times k will be equal to p. So will be equal to p, so k can also be written as p over h prime. So putting the value of k in our previous equation of total energy, we'll get E T is equal to not in this equation. We'll put the k's value in the previous equation of the differentiation, and we'll get d squared psi over dx squared is equal to negative k squared psi, which is equal to negative p over h prime squared psi, which will be equal to negative p squared h squared psi. And on further simplification, we'll get p squared is equal to negative d squared psi over dx squared times h prime squared over psi. So on putting the value of p squared in our total energy, we'll get e to the sub t is equal to p squared over 2m plus v, which is equal to negative d squared psi over dx squared times h squared psi plus v. Okay, so if I multiply this whole equation with psi, I'll get e psi is equal to negative dx and d squared psi over dx squared times h squared psi over psi. Actually I forgot to write something here, which is over 2m, 1 over 2m, so over 2m plus v. So this will cancel and we are left with e psi is equal to negative dx squared over dx squared times h squared over 2m plus v psi. Therefore e psi minus v psi is equal to negative d squared psi over dx squared times h prime squared over 2m, which implies e minus v. On taking psi as common, we'll get e minus v psi is equal to negative d squared psi over dx squared times h prime squared over 2m. And on shifting this part over here, we'll get 2m over h prime squared times e minus v psi is equal to negative d squared psi over dx squared. Also we know the value of h, therefore this thing will be equal to 2m over h prime squared will be equal to 2m over h over 2 pi squared, which is equal to 2m times 4 pi over h squared, which will equal to 8 pi m over h squared. And let me, for confusion, I'll make a little box outside this thing so that you might not be confused. Okay, so this thing can be written as, on taking this from here to here, we'll get d squared psi over dx squared plus 8 pi m over h squared times e minus v times psi is equal to 0. And this is Schrödinger's wave equation. And this one is in fact the time independent wave equation of Schrödinger. And on adding other coordinates, this is only a linear equation, but on adding other coordinates like y coordinates and z coordinates, this equation can be rewritten in the form of d squared psi over dx squared plus d squared psi over dy squared plus d squared psi over dz squared plus 8 pi m over h squared times e minus v psi is equal to 0. And this is the whole equation of Schrödinger. So guys, thanks for watching Physics Team. This channel is meant to be about physics and be interested in physics, and I'm hoping that you guys like this video and subscribe to my channel.